So in this video, I want to give a general overview of pointers. So to start, we know that if we want to store some bit of information, let's say we want to store an integer value, we can say something like int x is equal to 5. And what this does is it just creates some variable x, and that will point to the value 5 in local memory. What pointers allow us to do is they allow us to use allocated memory by storing memory addresses in the allocated memory. And essentially they just point to that place in allocated memory. So let me just delete this. And okay, so how do we allocate or create a pointer? Well, let's say we want the pointer to be called p. We can just say whatever type we want to allocate, we can say type star p is equal to alloc type. And this syntax is for C0. So for instance, if we want to create a integer pointer with the name z, we can say int star z is equal to alloc int. And what this would do is it would create variable z, and it will create a pointer to some place in allocated memory, like this. And for this box, this stores the int star type. So it would store something like this. And then this box will store an int like this. And then this box will have some sort of memory address, like I'll just give one a random one like this. And so right now, z, the value of z is this memory address right here. So what if we want to like assign a value to z or retrieve a value? So this is called dereferencing a pointer. So first of all, when you dereference a pointer, you have to make sure that the pointer is not equal to null. And that's very important. So let's say we want to assign a value to a pointer. We can say star, the pointer name, is equal to v to assign the value v to whatever the pointer is pointing to. So right now, z is pointing to this box, and in C0, the default value is 0. But if we want z to be equal to 5, to be pointing to some value 5, we can say star z is equal to 5. So when you see the star, you can think of it as like following the arrow. So you follow the arrow, and you can change, and we can change this value to 5. And let's say we want to get the value of a pointer. So if we want to, for pointer p, if we want to store the value it's pointing to in some type x, we can say type x is equal to star p. So let's say we want to store the value the z is pointing to into an integer y. If we say int y is equal to star z, this will essentially create another variable y, and it'll get star z. So you see the star, you can follow the arrow, and it'll just get 5. So this will make y equal to 5 in local memory. So I just want to do another example where, in this case, I want to explore pointer to pointers. So if you remember in this example, it's type star is p is equal to alloc type. This type can be an int, a bool, but it can also be another pointer. So for instance, let's say I want to create, I do int star star q is equal to alloc int star. This will create a pointer to an int pointer. So this will essentially say q, the variable q is this box, and it'll point to another box in allocated memory. And q is an int star star in this case. So like this. but this box now holds an int star. Like this. Okay, and I'll just give this box a random memory address. Okay, so for 2, this box is an int pointer, but it hasn't been allocated yet, so it doesn't have an arrow pointing out. So in order to allocate this int pointer, we can say star q, so we follow q's arrow here, is equal to alloc int. And what this would do, step 2, is now create another arrow into another address in allocated memory. And this box is now going to hold an int. And it would just have another random memory address. So I'll just give it that. And then, so now we have this kind of train of arrows. And if we want to change this value in the box here, we can say star q is equal to 6. So remember, when you see a star, you think of following an arrow. So star is equal to 6. So now we can just change this value to 6. So finally, I want to go over pointer aliasing, which can be a fairly confusing concept. So I'll just go through this example. So 1, I'm just going to allocate an int pointer like before. So p will be a int pointer type, int star, and I allocated an int, so I'll create a place in allocated memory. And this spot will hold an int type. And remember, for C0, it automatically initializes the pointer value to 0. Just a side note, when you move on to C, it doesn't do this automatically, so you have to be careful of that. But for C0, it'll make it 0 automatically. And I'll just give this place a memory address. Okay, so to move on to step 2, if we say int star q is equal to p, what this would do is it would create another variable q, and q is also an int star. And so we said int star q is equal to p, and p is equal to this memory address. So q is also equal to the same memory address. So it'll point to the same box in allocated memory. And if we move on to step 3, if we want to change the value of the q pointer, is say q star, or star q is equal to 7, we can say, okay, the star, we can follow the arrow up, and it's equal to 7. So we can change this to 7 for step 3. And now we can go to step 4, and it says star p is equal to star q plus 10. So what this means is that whatever p is pointing to is equal to whatever q is pointing to plus 10. So we see that q is pointing to 7, and we add 10 to that, so 17. So we said, so now p is pointing to 17. So this is equal to 17 now. And finally, this should be lowercase for step 5. So for finally, let's say we said p is equal to null. So what this does is it'll actually change p, the arrow p, to be pointing to null. And in our diagram, we can just draw something like this to signify null. However, q is still pointing to this spot in allocated memory.